So let's dive into functions and their inverses. So remember, we've spoken about what is a function and what is not a function. So if I have a graph, we can have a graph and it's possible that it won't be a function. So here, if I have a graph like this and a graph like this, okay, so how do we test if a curve or a graph is a function? So if I do this, I draw a vertical line test like this. So if the vertical line touches the curve once, therefore that is a function. If it touches it twice, therefore it is not a function. Now you know what is a function. So so we are going to talk about functions and their inverses. So what is an inverse? So inverse is something like the opposite. You are inverting something. Let's say if a clock is going clockwise, and then something that is an inverse will go anti-clockwise. So if I have a point that was starting with x mapped to y, it will now change the order to be y mapped to x. So I'm inverting the order. I'm inverting the order of x mapped to y to be y mapped to x. Okay. So now, if this is the function of f of x, the inverse will be denoted by this notation with a -1 to the top, like that. So that will be the inverse of f. So if this is the inverse of f, alright, so now suppose I was having a function that was saying if I have a point, let's say a, for f. Okay, if I have point a, let's say it's 2 mapped to 1, and then I have point b is negative 1 mapped to 3, and then this one c, it's 2, or let's say it's -3 mapped to 5. So the inverse of that point would be let me call that another point. Let me present it as an image like that. So the inverse would be 1 mapped to 2, and then this one would be 3 mapped to -1, and then this one would be 5 mapped to -3. Alright, so alright, so if you have done transformation geometry, you would see that this is a reflection about the line y is equals to x. So a reflection about the line y is equals to x. So what is the reflection about the line y is equals to x? So if I have a function here, so if this is a function, let's say it's one side of a parabola, so line y is equals to x, it will pass somewhere here. So the inverse of this, it will be something like this. You see? So this graph, it sees itself through the y is equals to x. So it is a reflection about y is equals to x. This one sees itself there. You see? So that's what it is. And then if I were to draw another part, Kamo, and then So this one would have the inverse would be like here, you see. So this one, it sees itself here, you see the head is there and then it's here. So and then yeah, so this is a reflection about the line y is equals to x. That is why we are swapping y and x. So if you look at it in terms of transformation geometry. But so since you have seen now that when we invert, we are swapping the x and y. So here's how we find an inverse of a function. Suppose I have y is equals to x squared, and then they say I must find the inverse of y. So the inverse of y, I would start by saying, by swapping the position of x and y. So I would say x is equals to y squared. Okay, so if I say x is equals to y squared, I then now write it in the standard form. We know the standard form of a function, y is a subject of the formula. So I'm going to introduce the square root both sides, and be careful, you introduce the square root of plus or minus. Okay, so here if I introduce the square root this side, the square root eliminates the square. So I will have y is equals to plus minus the square root of x. Okay, so if I have plus minus the square root of x, if you were to draw the function of plus minus the square root of x, it would be something like this. If you were to draw it, you would get something like this. So notice that this is not a function. It's a graph, yes, but it's not a function, because of, if I draw a vertical line, this graph fails the vertical line test. Okay, so this inverse, so if I can say this is f, and then this would be the inverse of f. So the inverse of f is not a function, but f itself is a function. You see, f itself is a function, but the inverse of f is not a function. So we are going to learn how to restrict the domain of the main function so that the inverse becomes a function. So if you can check from here, initially the domain of f, it's between negative infinity and infinity. Okay, this is the domain of f. And then now the domain of the inverse of f, we can see that is from 0 to infinity. Okay, so we are going to restrict the domain of the original function so that it yields a function as an inverse. Okay, so now if I say draw the graph of y equals to x squared, whereby x is greater or equals to 0, so I'm going to do this. So the graph would be like this, because remember, a parabola, it goes like that. But then I'm not interested in this part, I'm interested in the part whereby x is greater or equals to 0. Alright, so now its inverse, suppose here we have we substitute 1, y is equals to 1 all squared, that will be 1. So if I have here 1 mapped to 1, and then here maybe 2 mapped to 4. Alright, so if I were to draw the inverse, remember, if I have the inverse is to change the values of y and x. So if this were the initial values, and then the other one, it was 2 mapped to 4, then it will change to be 4 mapped to 2. Okay, so it will be 4 will be somewhere here, and then 2 will be somewhere there. So, and then we would have something like that, and then 1 map to 1 is still there, so we would have the inverse being like that. All right, why is it above like this? Remember that when you are doing an inverse, you are actually reflecting the original graph about the line y is equals to x, like that. Okay, so yeah, this is how the inverse will look like. So the equation of the inverse would be y is equals to the positive square root of x, the positive square root of x, and then this one would be x squared. So remember, we've restricted its domain. Okay, now we can be asked to draw the same function whereby the domain is less or equals to 0. So that would be the other part on the left, this one. So now this one, we will reflect it here. Okay, it will get this part. So this part, it will be y is equals to negative root x. Okay, and then so remember I said it is this function f. When we are inverting it, we are saying what is the image of this graph about this line y is equals to x, about this line. Okay, about this line. So you can see that this one, if I'm seeing myself through this mirror, my head will be there, and then if these are my knees, then I would see my knees there. Okay, so that's what it is. Okay, so now we can also have the inverse of logarithms of log functions. So logarithms are the inverse of exponential graphs. So if I have an exponential function and then I want to invert it, I'm going to get a logarithm. Okay, a logarithm. So now, for example, I have y is equals to a to the x. So, and then they say to me, find the inverse of this function. So the inverse of this function, what is the first thing to do is to swap x and y first. So I will say x is equals to a to the y. Okay, so I'm going to introduce a log. So the log that I'm going to introduce is this kind of a log. Let's say the log of, let me use x and y, something like that, or m and n, yeah, or m and n, something like that. So there's another log we call base 10 log. So base 10 log, where there's n, there's always 10. Let's say here there will be m. So but we don't show the 10. It will just be log of m. So log of m, where do you see it on your calculator? This one, it's base 10 log, and this one is a normal log. Okay, so and then now I'm going to use this one to solve this. I can use both of them. So I will say y is equals to, remember I want to make y subject of the formula, y is equals to the log of x, which is the answer, log of x base a, and then that's it. Okay, for example, another example, if I had y is equals to 2 to the x, and then I want the inverse of this, I would start by saying x is equals to 2 to the y. I make y subject of the formula. I will say y is equals to the log of x base 2, like that. Alright, let's try another one. You can try this. what are you going to do? You are going to say, you start by swapping x and y. You say x is equals to 1 over 2 to the y, and then you're going to say y is equals to the log of x base half. That's how we find the inverse of an exponential function. That's what you need to do. So how does it look? Let us check. So if I can draw an exponential function, y is equals to 2 to the x, so we know that its y-intercept is 1, it cuts at 1, and then its asymptote is the x-axis at this point, so it's going to go something like that. So as it goes like that, now remember, here we have 0 mapped to 1. Okay, so here if I were to substitute 1 here, and then I would have a point 1 mapped to 2. Okay, 1 mapped to 2. So let's check. I have a point that is 0 mapped to 1. I have a point that is 1 mapped to 2. And then, okay, let's try another point. Let's say I substitute 2. It will be 2 mapped to 4. So now I have a point 2 mapped to 4. So if I invert it, it will be, this one would be 1 mapped to 0 for the new function. Let me use a different color. For the new function would be 1 mapped to 0, 2 mapped to 1, and then 4 mapped to 2. So now here I would have 1 here, it will cut here, 1 mapped to 0. So now remember, the asymptote was the x-axis, but now because we are inverting, it's no longer the x-axis, it is the y-axis. So now I have a point there, and then 2 here, and then 3, 4. So now it is 2 mapped to 1. 2 mapped to 1 is somewhere here, and then there's 4 mapped to 2 somewhere there. So and then it shows, it goes something like this. Can you see? So, and the asymptote changed from being x to being y, so it will go somewhere like this. What did I say an inverse is? It's just reflecting the original function about the line y is equals to x. So where does the line y equals to x pass? It passes here. Very nice. So this line is y is equals to x. That's what doing an inverse is. So this one, you can see that it can see itself through the line. Can you see that? So this is the inverse of that. So this inverse, it is defined by y is equals to the log of x base 2. Alright, so you can practice other functions and do your logs there. Okay, thank you.